Hi, this is Charles DiMaggio. Welcome back to R for Epidemiology. What I want to do in this screencast is introduce the topic of an R matrix. And in my initial talk about R objects, I mentioned that an R matrix is nothing more than a two-dimensional vector. And we've already spent a little time talking about vectors. Importantly, a matrix, and we're going to be using this notation a lot, is indexed using the bracket notation with the row dimension separated from the column dimension, separated by a comma. And we're going to talk a little bit about creating R matrices, naming R matrices, getting a matrix using a table function, indexing R matrices. So let's just get right into it at this point. If I were to, what I did is I've taken a little code and put it here to save some time. I want to create a matrix, and I'm just going to put this aside for a moment right now, but let's just get rid of that. I use the matrix function to create a matrix. I'm calling it my matrix. I could have called it anything I want. And the arguments to the matrix function are a set of data where here I just have 4 letters, and they're enclosed in quotation marks, which means that they're characters, and then the instructions or the dimensions, and it's the row numbers. I want a 2-row matrix followed by the column numbers. Now, to be honest, I should have really just used, I think it's row, no, well, let's find out exactly what it is, and that's why I had that over here. So if I were to bring up the help page for the matrix function, what I would get over here is, okay, matrix creates a matrix, I know that. And there is an argument called ncol for the number of columns, and a function called nrow for the number of rows. So what I really should have done here is I should have written nrow equal 2 and ncolumn equal 2. That's good programming, that's better programming. But in fact, if you make sure that you put your arguments in the correct order, R is smart enough to know what the arguments are to which you're referring, and I tend to do that to save a lot of time. I probably shouldn't, but here I'm going to do it. It's relatively straightforward. I submit that. Let me get this out of the way, and if I were to take here is my code. I'm creating a matrix out of these 4 letters, and I want it to be a 2x2 matrix. If I look at the matrix itself, it looks like this, and it is A, C, B, D. Kind of familiar to epidemiologists, is it not? The classical 2x2 table, except it's a little weird here where I have A, B, C, D. I know I intuitively expect a program to populate a matrix or a table row-wise. R doesn't do that by default, but there is another option called by row, and I set it to true. By default, it's set to false, but if I set by row to true, what R will do is it will populate the matrix row-wise, which is what I really wanted to do. A, B, C, D. This looks very much like the usual matrix, that the 2x2 table that epidemiologists are used to working with. There are a couple of functions that you could use to pretty things up at this point if you really wanted to. You could use the column names function and the row names function. The way these work are, so if I were to, it's a function that returns the names of the rows and the columns in a matrix, right? So if I were to ask for the column names in this particular matrix, the number here, the column name is null. There are no columns named. So what I'm going to do then is I am going to actually name those columns. I'm going to give R these 2 names, case and control, which is using the concatenation operator to create a vector, and I supply that vector to the column names function. It's a little weird to see the arrow going in this direction towards the function. Usually it's a function going towards something, but that's the way this works. Submit that, and I'm going to do the same thing for row names. Now if I bring up my matrix, I have a nice named matrix of some kind. And at this point, what makes sense is to have a sense of how you could work with some of these numbers over here. Here's my recommendation to you. When you index a matrix of any kind, there are a couple of ways we could do it, but what I would really recommend is index the matrix with row separated by column of some kind. So how would this work? Well, if I wanted just the letter A over here, what I would say is I want the first row going in this direction, right? Whoop, going in this direction over here, right? And the first column going down in this direction over here. And if I were to do that, it would be the first row by the first column. I submit that, and I get the letter A. Let's say I want the letter D. Well, that's the second row, second column element over here. And I would just put the second row and the second column, submit that, and I get the letter D. That, to me, makes the most sense. If I want the entire first row, if I want A and B for some reason, I want to do something with it, what I would do then is I would just specify the first row and leave the column dimension in the indexing bracket blank. And that should return A and B to me for this particular matrix, and A and C. A and C. Oh, I'm sorry. Why is it returning that? Oh, because it is my matrix. It's the first one I made. This should be my matrix 2, which is the one that I created that was row-wise. And there you go. A and B, case, and control. And that works well. I want to mention one thing here. Remember I said that a matrix is really a vector with instructions? There is actually a way, and I find it confusing. I'm just going to put it in here just to let you know. If I were to index my matrix 2, right? And I were just to index it like so, with a single number, and let's say that number is 4, I would actually get a result. I would get the letter D. But that gets a little confusing. This will always work, no matter what the dimensions of the matrix are. For a simple 4-element matrix, just indexing with a single number might actually work. I'm going to mention it here, and I want you to forget it completely. All right. Now, that is how we basically index matrices. One of the little tricks you could do, and what comes in handy, especially if you're doing epidemiologic analysis of some kind, is sometimes you need to transpose the columns or the rows or the columns and the rows for a matrix to put it into the kind of format that a function you're working with would work. So, for example, there is the epi_tab function, which within the epitools package that I've mentioned. The eptab function requires a matrix, a 2x2 matrix, but it requires in a very special way. It wants the unexposed on the top and the untreated on the left side. Sometimes your data comes that way, sometimes it doesn't. But what you can do is it's kind of a trick, or it's a little trickish in any event. But if I were to bring back my matrix right here, okay, let's do that. Here it goes, my matrix, A, B, C, and D. Let's say I need to switch these around. I need the cases and controls switched in some way. I need the columns switched around. There's a very simple trick to do that, and here it is. I know it's the column dimension that I'm working with, so I want to be on the right side of the comma over here. And what I want is, remember, indexing, depending on the order in which you put the index, it will return that. So what I want is 2 and then 1 in the column side. So this little transposing trick essentially brings the A and C over to the right side. Notice here, it's case and control. Now it's control and case. I could do the same thing. I'm going to copy this, control copy, paste it over here, do the same thing. But now I'm going to work on the row dimension. Now what I want to do is I want to take exposed and put it on the bottom and put unexposed on the top. And if I do that, here's what I get. I get the unexposed on top and the exposed on the bottom. It's a little trick. It'll come in very handy for you. As a matter of fact, I believe in one of the exercises I have for this particular course, you need to use this when working with the eptab tool. Now, sure, it's simple if you have like these, if you have some data and you're just putting in there and you know the numbers themselves. Let's say you had a data set, like a real data set of some kind, and you wanted to create a matrix of some kind. Well, it's relatively simple to do. I have a data set on my website called the Digitalis data set that I got from an NIH site of some kind. I forget, I have the details there. But the Digitalis data set is a relatively famous data set that looks at the effect of digitalis treatment in the setting of myocardial infarction and its effect on mortality. And it's a full data set, individual level data set. And I'm using this read CSV function here, which I haven't introduced yet, but I just want you to get a sense of how you might create a matrix with some other functions within R. So let's say I have this big data set. I'm just going to read it in here, and you can get the location of this data on my website itself. I'm going to finish reading it in here, and it's read in. Basically what R did, very, very cool, went to my website, found the data set, read it in. After I've read in my data set, I can create a table, a 2x2 table, using a couple of simple functions within R. And the first function I'm going to use, that makes the most sense, is the table function. And the table function takes as its arguments the 2 dimensions from which I want a table. And I want a table where I have treatment, TRTMT, in the row dimension, and some sort of outcome, and in this case I'm going to use death in the column. And if I were to do that, what I would get back over here is this particular table. I can save this table right here as an object itself, and I would call it my table or something along those lines. My table, and if I save that, now I have my table. And I can now bring my table back up if I really want to over here, and I get the exact same table over here. One thing I want to mention is that you could come up with really a very nice way to label a table like this if you wanted to, and it's called the dimension name function. In the same way I use the column name and the row name function, I submit as my argument to the dim names my table. And in this case, we're going to have to give a kind of specialized structure. Whereas before I could provide a simple vector, now I have to provide a list, which we haven't spoken about yet, but don't worry about it right now. So it's a list, and what I want is, let's say, treated in the row dimension, and treated is equal to, and now for a list, it's a list of two vectors. Treated is a list of with the first vector being, we'll just say yes or no, and then the next one is no, and then in the column I have, let's say, outcome, and outcome is equal to another vector. In this case, it is died, and let's say lived. And let's submit that and see what happens. Okay, good. Now let's bring up my table. And my table, now I have a nice little 2x2 table. If I wanted to, I could actually index these numbers and create a simple odds ratio, and maybe we should just do that here. Let's just do that very, very quickly, okay? My odds ratio is a calculation where I first want I want AC over D. So I want my table, and I have 1 times the C element, which is AD over BC, the D element, and the D element is 2. So it's my table, and then that's indexed as 2. And then I want that divided by, and I'm just going to nab this over here just to save a little typing. Copy, put that over here. And then I want B, which is first row, second column. So that's first row, second column over here. And then I want C, which is second row, first column. Make that 1. And just to make sure that the calculations turn out the way they should, I'm just going to make sure that I do my order of operations, keep things within the kind of parentheses that they need. If I submit that, error at my table not found. Why is that not found? How is that possible? Did I just create my table? Oh, because it's capital M. Of course it's not found. R is very strict about that kind of stuff, and I need to make sure that this is not capital. And let's try and run that now, see what happens. There we go. So let's take a look at my odds ratio. I got an odds ratio. Doesn't look like the joction had very much to do with preventing or causing death. In any event, that's a quick introduction to vectors, and next we'll be taking a look at arrays.